So you're going to have 3 tasks on this the hydrocarbon isomer project. Most of it you're going to have to do at home, but it's not that big of a deal. Okay, I'm not wanting you to go spend a bunch of money or anything like that. You can use stuff around your house, or you can go get a bag of marshmallows, okay, or a thing of gummy bears, okay. But you can use whatever. You could use clay and a string, any object that you have around your house that represent an atom and a bond or bonds. All right. So the first thing we're going to do is we're going to go through and we're going to work together and we're going to do the isomers for C6H14. Okay. And if you're like, I don't know what an isomer is. All right. Well, here's a stupid example of what an isomer is. An isomer is kind of like this. All these people are named Chris Stubbs, but only one of them is me. All these other people, well, I guess there's 2, there's me too, but all these other people, okay, they don't look like me, but we share the same name. Isomers share the same chemical formula, but they have different structures. So you have to name them differently. But they still all have, in the case of this, 6 carbons and 14 hydrogens. Does that make sense? They're just arranged differently. Okay, so the first thing we need to do when we start this project is we are going to, if I can find the thing here, we're going to take 6, and I'm leaving off the white balls. You guys will need to put the white ones on, all right? But I'm leaving them off because there's no way I'm going to be able to show all these, like I said earlier, with the amount of time. So I don't want to like take up all of your time for this. All right, so 1, 2, 3, 4, 5, 6. The way that you guys will do this, okay, and again, you'll have this filled up. You'll have 3 hydrogens here, 2, 2, 2, 2, 3, okay, is you'll draw it out on the sheet of paper, the paper that I gave you, okay, the white paper. You'll draw it out like this. You'll label it. This is hexane. And then you'll put the chemical formula. Oops. C6H12. All right. So our first isomer, number 1, is right here. So you get your phone out, click, and take a picture of it after you're done. Does that make sense? So then all you've got to do is after you've got like this arranged, don't tear it up. All you'll do is take one off the end. And remember, you've got 3 white balls around here. Okay. And what you're going to do is put it someplace. Don't put it over here, because if I did that, I still have hexane, right? That's still hexane. So put it in the middle. Remember what I said about alkyls? They have to go in the middle. They can't go on the ends. So put it right there. And then redraw this. 1, 2, 3, 4, 5. And then go like that. And remember, what's at the end of this line right here? What's right there? A carbon. That makes sense? So if you count these, look, watch. 1, 2, 3, 4, 5 is my chain, but there's my 6th carbon up there. I didn't do away with it. It's still there. Look, it's still in the diagram. So then once I've drawn this out, I'll name it, and it's a pentane, right? Off of the second one, we're going to call this methyl. So another isomer besides hexane is 2-methyl pentane. Take a picture of it. Make sense? Then I can move this to the middle. Redraw it. That was a pretty simple one. 3-methyl pentane. If you're like, I don't, because if you start messing with this and you pull these around, you're like, well, maybe I can do an ethyl. So you do this sort of thing. Whoops. I got a runner. And you're like, okay, well, I want an ethyl group. So you have it looking like this, right? You think, look how cool I am. I made an ethyl right here because it's got two, right? This would be an ethane. I attached it to what I thought was butane, right? And then you put this right here. Like, oh yeah, that's got to be an isomer. Yeah, we got a slight problem. Watch. That's 3-methyl pentane. That's the same thing. Did you see what I did there? You thought it was the longest chain was a butane, was a 4, right? I thought it looked like that. And then off of this one, you had this sort of thing. There's a problem with that. 1, 2, 3, okay, 4, 5. It actually, if you rearrange these, because remember these can spin around, it's back to this thing that we already did. We already did that one. So just be careful. Google them. Google isomers of hexane. There they are. Click on images if you have to. Find them. There they are. Okay. You're just going to draw them, make them, okay, out of whatever you got to. That will be task 1. And then in task 2, all you do is you make an alkane with an alkyl functional group. I don't care what alkane it is, and I don't care what alkyl group it is. You just make one, just like you were doing up here in the isomers. And then you'll make an alkene that's going to have a double bond with an alkyl group. And then you have to name it. You have to always do it the same way. Make it, draw it, name it, and then give the chemical formula. Does that make sense? So you'll do all 4 of those things. Make it, draw the structure of it, name it, and give the chemical formula for it. Okay? The only thing I haven't covered yet are the cyclos. And let me do that really quick. It's simple. All the cyclo does is this. It turns in on itself and forms like a geometric shape, like a pentangle, like 1, 2, 3, 1, 2, 3, 4, 5, 6. Actually, it's a hexane. Okay. Or a hexagon, I guess that would be called a hexagon, right? So it looks 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah. Got it? So this guy is going to have 2 less hydrogens, right? Because I took 2 of them off the ends. On all ends, there's 3, right? So we removed 2 of them. So hexane is C6H14, and cyclohexane is C6H12. So cyclos have 2 less hydrogens because it's bonded around. This would be cyclopropane. Okay, this box 1, 2, 3, 4 would be cyclobutane. And if we put like a little thing over here and did that with an OH, cyclobutanol. And we did this, and you put a little F right there. This is 1-fluorocyclobutane. It can get kind of cool. You start doing a bunch of these. Okay? All right. I think is it about 12:20? Good? Okay. I'll shut up, and you guys can work on the isomers.